Okay, so I'm going to do this on the screen. I'm going to assume that you'll follow along in your TI-83s. But we just need to make a small connection here in the beginning of it. So here's a strange looking equation. Not one that you'd be expected to solve by hand, but one that we could do with the TI-83. So if I'm trying to figure out where this equation is equal, one thing that it could be helpful to do is think of this as two different functions. One that is tangent of sine of x, and another one which is the value 1. Okay? So let's load that up in the graphing calculator just to see what it looks like. So y equals tangent of sine x. So that's what the first graph looks like. And the second one, if we think of it as two pieces, y equals 1 looks like that. So what I want to do is we want to figure out how many solutions there are from 0 to 2 pi. So maybe I'll change this to be trig coordinates. Okay, so you can see where 2 pi is. Here's the beginning, and here's 2 pi over here. So how many solutions do you think there would be where the number 1 is equal to the sine of the tangent of x? Sorry, the tangent of the sine of x. Yeah, it's funny that algebraically we seem more confident, but the picture actually shows something you might remember from grade 11. Remember doing systems of equations? What did you learn about the picture for a system of equations? Yeah, what about that, DJ? Yeah, where they intersect is where you find their answer. That's where they're equal, right? The graph is showing where these two are equal. There's one spot right there. Right there, the other spot right there. That's where they're equal because that's where they meet in the same place, right? So I can see from 0 to 2 pi that these are the 1 and 2 solutions that we would find in this graph. Okay, so there's actually 2 solutions. And the number of solutions is the same as the number of times the graphs intersect. So that's the important idea, is that we know that however many times they intersect, that's how many solutions we find. So now we have to figure out how to do this for a non-graphing calculator portion. Ooh, yeah. So let's try it. And what we're going to do is we're going to try to be the graphing calculator, okay? But I'm going to show you a better strategy, because it's possible that you draw a beautiful graph for this and then actually put it on the proper range and count. But I'll show you another strategy as well. So let's try the first idea. If I was to go and draw the graph 3 cosine 1/2 x, then it would start at the value 3, and then it would hit center line and then minimum. So here's a sketch for that graph, and it wants to know where it's equal to 1. So there's the line y equals 1. So how many solutions are there? Uh-oh. Have you been mathed out so far? Double block? Yeah. We're almost there. One solution. Yeah, there's one solution. One time when the graphs meet. That's the time from 0 to 2 pi, they meet the one time. Okay, here's a strategy, though, that can help us save some time. We're going to go like this instead. It's more general. And say, there's a cosine graph. Okay, there's the graph y equals to 1. For one period of the cosine graph, how many solutions are there? 2, yeah, that's correct. So you don't even need your toes to count this one. There's 1, 2 solutions. And how many times will I see this graph if I give you 2 pi worth of space? Well, to answer that question, I need to know that the period here is 4 pi. So I have 4 pi to get one cycle, but I only gave you 2 pi. So how much would you expect to see? Well, only half is going to fit in. So this only happens for half a cycle. So 2 solutions, half a cycle, that gets you to 1. Okay? So we'll try it again and see what you think. Most people actually prefer this as they get used to it. Okay? So let's walk through this one. Sine 4x equal to a half. Okay. So here's my sine graph. It doesn't even need to match the picture yet. All I do is look at one sine graph and one y equals to a half. There's the half. Okay, so here's the toughest part of it. How many solutions are there in the one period?
2.
Somebody on this side, help us out. How about Tom? 2, yeah. So you can see there's 1, 2 solutions for that single period. Now we have to ask ourselves, how many times will this graph appear? So I have 2 pi of space, and what's the period of this graph? Pi over 2. Okay, so how many times will that graph fit from 0 to 2 pi? 4 times. Yeah, it will happen 4 cycles. So 2 times, every time I see a cycle, 4 cycles happen. That means there will be a total of 8. Okay? So we getting the number of solutions here, it's going to be related to the period of the graph, because that's going to tell us how many times it repeats itself. Okay? So we should be able to do this with a letter as well. So for example, in this one, I'm going to walk you through it with a couple strategies. Okay, the first one is going to be exactly what we did. And then the second one, for those of you who don't like working with letters, I'll show you how to do a little experiment. Okay? So first of all, let's just pretend that A is there. We got to deal with it, but we don't even need to ask ourselves about A yet. Here's one graph. Here's a half. So there's 2 solutions. Now this is the trickier question. How many times will this happen? Well, let's not worry about the fact that there's an A there. Let's break it down to the same questions we had before. How much space do I have? Well, there's 4 pi worth of space. Okay. What's the period of this graph here? There's going to be an A in the period, but I think you can handle it. 2 pi over A. So if I have 4 pi worth of space, and I need to divide it into chunks of 2 pi over A, then that's how I can find out how many times it happened. 4 pi, split it up into this many cycles. Okay. And one thing we could do here is multiply the top and bottom by A. Get rid of that nasty fraction. So this will become 4 pi A over 2 pi. Pi's disappear, and I'd end up with 2A for the number of answers. Okay? So 2 solutions happen. How many cycles will I see? I see 2A for the number of cycles, so the answer would be 4A solutions. Okay, so that's pretty abstract. I realize that. I'm going to have to go into the next space here just to show you a little experiment you could do. So let's just say that we were down here doing some rough work. I'll have to erase this after. We could say, here's the sine of x. Okay, A equals 1. There's 1, 2 solutions to the half. Sorry, I lied. I have to go all the way to 4 pi. So there's 4 solutions when A equals to 1. Let's make A equal to 2. Now I'm going to find that there's 1, 2, 3, 4 graphs. And 1, 2, 3, 4, 5, 6, 7, 8 solutions. Right? We could do it as, what if A equals 1/2? Now the period is 4 pi, so I will only see that graph one time. 1, 2 solutions. And then from this, you can look at your choices to see the pattern is 4 times A, 4 times A, 4 times a, and I end up with 2. Okay, so you can also run it like a little experiment. So try the last one with whatever method you think is best, but that is also a thing you should be prepared to deal with, is what if we throw a letter into it? Okay, so I'll leave it on there while you work on the next one. Okay, so I'm going to have to move all that rough work off for the experimental kind. So, number of solutions. This time I'm looking at cosine. So here's a cosine graph. Okay, here's the value -1. Oops, let me do a better job of that. Here is -1. So there's only one solution. Okay, one solution in each cycle. The period will be 2 pi over b, and I have 4 pi of space. So 4 pi divided by each cycle will be 2b is the number of cycles. So 1 times 2b is 2b or not. Never mind. Yeah. But however you did it, that's the pattern that's connected to. If you put in the number 5 for b, you will see 5 solutions. If you put in the number 1/2, well, you would only see, let's see here, 1 solution on that graph. Okay? So that's the end of us for introducing trig equations.